What's up, people? This is Vishal, and welcome back to another code long session. In this session, we'll be continuing to work on our simple maths library and start making improvements in it. So let's go. So let's quickly look at what we have written so far. So we created a function called maths, and which is setting a confined scope of result, and we are returning a set of operations which is working on those result and returning the same object. And because it is returning the same object, we'll be able to do chaining in the way we are calling the function. So now the problem with this approach is this works very well for a limited set of operations. Let's say in future we want to add more operations, maybe 100 more operations or 1,000 more operations, then this function will basically be returning a very big object, and each time we call that function. So let's say I want to call this function at multiple places, then I'll be creating multiple variables which is going to hold the same size of object, which will eventually consume a lot of RAM and basically make the performance of the browser slow. So to avoid this problem, we will go away from closures now and move towards the concept of classes. So let's see how we can improve this function. So I'll just get rid of everything for now, and let's create a function maths, and this is going to take an input of init, which is by default 0. So we'll have this dot result equal to init, and it will have a function called get result, which will return the result. Okay, so let's comment these things out and first see what is happening. So we have a function maths, we are creating using this variable and setting a result of initializing the result, and we are creating a helper function called get result, which is going to return the result. So right now this is not going to do anything, so we'll just refresh and see what is happening with the maths. And inside our maths function you can see that there is a prototype key. Okay, so we'll be using this prototype key to add our operations into this function. So so let's move ahead and add our operations to the prototype object. So we will write maths dot prototype dot add equal to function. Let's move this a little more down, and let's add more functions, all the operations here. um, okay, so we'll have subtract, we'll have multiply, and divide. So there will be no change in the logic, so we are going to fast forward that. Okay, so let's look at what we have written. So all the calculation logic is same. The only change that we have done is instead of returning the object operations, this time we are returning this, because this is maintaining the scope of the result plus the get result. So every time I return this, I'll have access to uh, the result, the get result method, and due to prototype chain, I'll also have access to dot add, subtract, multiply, and divide. So let's see how we will execute this. So let's uncomment everything. Now if you see the error message over here, it says insert the new keyword. Why? Because we have converted our method into a class. So we'll write new here, and you'll see that all the methods have got the references now. So yeah, let's save and refresh. Okay, yep, and you can see that the result is 26, just like our old case. So we've maintained our chaining, and the only thing that has changed is the way we have written our library now. um, Now if you notice one more thing, So if you see maths here, and this you'll see there is a prototype chain, and inside this prototype chain I have all my methods. The good thing is, if you notice, I'm not writing when I'm calling this method, I'm not saying maths.prototype.add or maths.prototype.multiply, because prototype is a special keyword in JavaScript, and due to prototype chaining, it will always be in the context of this. So if I write maths.add, it is basically going to search in the prototype chain as well. First, it is going to search immediately under the maths object. It doesn't find it, so it will look for that method inside the prototype chain, and it will pick it up from there. Okay, so this is fine. Our result is coming fine. Our methods are right here. Now, what else can we do in this? We can do another thing, which is instead of writing this dot result equal to init, let's write it as let result equal to init. Now, what happens with this is we are not allowing access to directly modify the result. It will always happen through a function. So we already have a function which is doing uh, get result. Let's also add a function this dot which will do set result, and which will take an input of a function, and which will say that this will be a this will take an argument and will say result equal to number. Okay, so all the now we'll have to change the implementation of everything over here. So instead of this dot result, we'll write let result, and instead of this dot result, we'll write this dot get result. Okay, so quickly explaining what we are doing here. Instead of directly accessing result, now we are calling the function this.getResult and trying to access the value, and we are assigning it into a local variable called result. Now we have to set this variable into our store. So we'll just say this dot set result and pass our result here. Okay, so this is basically setting the value. Now we'll have to make this change everywhere. So let's quickly do that. Let result equal to this, and this dot get result, and we'll have to write this dot set result of result, and here again let result equal to this dot get result into multiplier, and this will carry forward, and again here we'll write let result equal to this dot get result divisor, and we'll copy paste the value. All right, so now if you notice, we do not have any direct access. So instead of returning this dot result, now our maths function is basically returning this dot get result and this dot set result, and rest of the methods are in the prototype chain. So now whenever I create a new object, this is only going to store two operations, which is get result and set result. Unlike our older case, which was going to hold all the operations together. Uh, the access to the rest of the operations are happening because of the prototype keyword. And so the way it works is very simple. It will try to look for the immediate child, and if it doesn't find it, it will try to look for the method inside the prototype chain. And if it finds the method, it is going to be accessible via this. So that's what is happening over here. So instead of directly accessing the result, now we are yeah, one more modification that we need to do. Yeah. So instead of directly accessing the result, now we are doing all the operations and setting the result individually after each operation. And we are already returning this, so we'll be maintaining our chain. So let's save and reload. You will see that the output is 26. So now we'll look at how we can extend this library. So every time I want to add a new function, I either need to do as a author of this library, I can add the function like this maths dot prototype dot let's call it square, which is going to be a function, and this is just gonna do so it will be like get result equal to this dot get result and power of 2, and we'll just say this dot set result equal to result, and we'll say return this. Okay, so now instead of get result immediately, I'm gonna do square, and then we'll say dot get result. Then we will have the result inside our function. Refresh, we'll see that 676, which is square of 26. So now, as an implementer, let's say I added a new function. So I am implementing this library further. So this function is not a part of the library, but when I'm implementing this function into my code, I want something which is one more operation in my code, which is cube. So I created a quick function maths.prototype equal to cube function equal to this, and there is the implementation, and I press enter. Now if you see maths, so you'll notice that the prototype chain now has the cube as well. So this is done by the implementer. This is not given by me as an author of the library, but as an implementer, I was able to add this. Now we'll create const maths equal to new maths. We'll initialize this to 5, and okay, I think we have already initialized it before, so let's call it maths2. So now we'll say maths2 dot cube, and we'll say get result. So you'll see that 5 cube is 125, and now our library is really good. Now it has the capability of extending into n number of operations. It can be either added by the implementer or given by the author, and my code looks more structured now. So all the operations are together, my class is together, and all the operations have their own prototype, and they are written nicely, and we are implementing it, still implementing it, following the same chaining methodology. So that's all for the solution, guys. I hope you loved the new approach, and I hope this video was useful for you. And please like and share this video with your friends and any other person who you think will be benefited by these. Please subscribe to my channel for more such code alongs in the future, so that we can work on more such interesting problems together. That's all for this one, guys. Thank you.